Now, they say sample of U is completely neutralized by sodium, by potassium hydroxide. This is alkali, or you can think about it being a base. That's because this is an acid. Again, you should read the question. All right. Now, 1 mole of U reacts with 2 mole of KOH. 1 mole of U reacts with 2 mole of KOH. Now you need to think carefully. First of all, it's easy to work out the mole of KOH because you are given the concentration, so 0.150 mole per dm cube. So when you multiply by volume, this is in cm cube, so you need to multiply by 10 to the minus 3. That means you divide by 1000, and in doing so you convert the cm cube to dm cube. Per dm cube times dm cube would cancel out. That's why concentration times volume in dm cube is going to give you number of mole for solution, which you know from doing all your theory as well as all your practical course, of course. All right, so the mole of U over the mole of KOH is 1/2. It is this statement there. 1 mole of U reacts with 2 mole of KOH. 1 mole of U reacts with 2 mole of KOH. So the mole of U is half times the mole of KOH, which was calculated in step 1. So that's going to be 9.525 times 10 to the power minus 4 mole. I do not want to round it up that early yet, okay? So they want you to calculate the relative formula mass, basically the MR of U. You know the mass used, and you want the MR, and you also know the mole. So it's a solid here, it's a solid, okay? Therefore, you know the mole of solid is going to be the mass of the solid divided by the MR of the solid. Mass of MR will give you the mole of the solid. We are talking about solid here. We were talking about solution. All right. So now 9.5. Well, actually, I don't need to write down. You want the MR there, so you would bring up the MR and you would bring down the mole. So the MR of U is going to be the mass of U, which is 0.086 gram, divided by the mole of U, which was calculated in step 2. And that means you would get 90.29. They don't say how many significant figure, right? Just now here they say, well, they didn't say anything. But here, what do you notice? I use a different color. Yeah? There's 1 and 2. This is 2 sig fig. You don't count the 0 in front. Yeah. When you do significant figure, there's 3 significant figure here. 1, 2, 3. There's 1, 2, 3. Okay. If you do physics or if you do any science, you should know something about precision, accuracy. Your maximum accuracy here is 3 sig fig. Okay. So you should probably leave your answer to 3 sig fig, and the unit is gram per mole. I mean, does it make sense? Gram per mole. In 1 mole of the substance, this is the mass. Well, that's the definition of MR, right? What is the mass of 1 mole of the substance? In 1 mole of the substance, this is the mass. All right. So the relative formula mass, well, is for ionic. Not ionic. It might just be not a simple molecule. That's why they use relative formula mass instead of relative molecular mass. Okay. Now they want the remolecular formula. You know the empirical and you know the total mass. So we are looking at something like this. CHO2 multiplied by something will give you 90.3. For this alone, it's going to be 12 plus 1 plus 2 times 16. Altogether, multiplied by n will give you 90.3. Alright, so 12 plus 1 plus 2 times 16 is 45. Multiplied by n will give you 90.3. I can immediately tell you n is going to be roughly 2, but because there's a 0.3 there, so that's a bit annoying. They wouldn't give you a perfect whole number, but you will still get like 2.007. You know it's a whole number because it cannot be a decimal, right? In terms of molecular formula, so you need to be a little bit more sensible. Okay, these are experimental results. Of course, there's bound to be a little bit of error. Okay, but in terms of molecular formula, it doesn't have a decimal because it's the actual number of atoms in one single molecule. That's the definition of molecular formula from your O level. which you should know anyway. Yeah? Okay, the actual number of atoms in one single molecule. Alright, so I just multiply 1 by 2, 1 by 2, 2 by 2. Okay. Now, they tell you W, they give you the mass. They want you to find the relative formula mass, meaning to say the MR of W. With this and this, you can work out the mole of W, which is equal to mass over the MR. Alright, this information is important based on this. Alright, so what are we looking at? We don't have a balance equation, but they give you the mole ratio. 1 mole of W reacts with 3 mole of KOH. So we are going to use that. Alright, so I'm going to work out the mole of KOH first because I have the concentration 0.250 mole per dm cube. Okay, so you should also be aware that mole per dm cube can also be written as mole dm minus 3. This is in your O-level mathematics. You can choose to represent it like that. Yeah, they are the same. That multiplied by 18.5, but that is cm cube. So cm cube to dm cube, you're going to 10 to the minus 3, and that's exactly what I'm doing here. You could divide by 1000, it's the same as multiply by 10 to the power minus 3. 10 to the minus 3 is 1 over 10 to the 3, is 1 over 1000. Oops, 1 over 1000. So that is your O-level maths again, yeah? So that will be in dm cube. Concentration in mole per dm cube times volume in dm cube is going to give you mole. Alright, so the unit makes sense. 250 times 18.5 divided by 1000. That's 4.625 times 10 to the power minus 3 mole. Now your mole ratio says the mole of W reacting with KOH. 1 mole of W reacts with 3 mole of KOH. That is this information here. 1 mole of W reacts with 3 mole of KOH. I love my fraction like this because this is mole ratio, this is mole ratio based on this or from balance equation. And from there I can work out mole of W is 1/3 times. I move the mole of KOH up there, multiplied by 1 over 3, which is this, multiplied by 1 over 3. Okay. Do not run off your value too early, yeah, okay? So you should keep it until the very end. That is going to be 1.5417 times 10 to the power minus 3. That's the mole of W. But then we also know this, okay? So the mole of W is equal to 0.194 divided by the MR of W. And I want the MR of W, so I can just 0.194 divided by the mole of W. Make sure you copy the right thing, okay? Make sure you can double check your calculation because these are the common mistakes that people make. For when I say people, I mean O-level students, alright? That is roughly, have a look at the data given. This is 1, 2, 3 sig fig. This is 1, 2, 3 sig fig. This is 1, 2, 3 sig fig. It would be wise to leave it to 3 sig fig. Okay, remember this is in gram, this is in mole. I have, this is mole, I have swapped it with MR. MR goes up, mole goes down, so gram per mole. The unit is actually gram per mole, and that is MR. 1 mole of a substance has this much mass. Alright? I mean, you could forget the unit, I guess, and you still be alright. But, you know, that's just mathematics for you. So the units there probably wouldn't count against you, yeah? So you have the empirical formula, which was C2H2O. So C2H2O, N is going to give you 126 roughly. So that is 12 times 2 plus 1 times 2 plus 16. The whole thing multiplied by N is 126. 12 times 2 plus 2 plus 16 is 42. So N is equal to 126 divided by 42. That is 3. So meaning to say, your molecular formula is going to be C2H2O 3. So it's C6H6 or 3. Okay. Now this is a calculation. They want you to calculate the minimum mass of sodium in gram. They told you hydrogen gas. So hydrogen gas is H2. It is a molecule, not an atom. 3 sig fig, okay? When I do calculations, I like to do ratio like this. So I know I need sodium, so there's sodium. I know I need to relate to hydrogen, so these are the two mole ratio that I need to relate to. You can have them one way around or the other. It doesn't matter, because what have I done? I've done the mole of sodium divided by the mole of H2. What does this equation represent? There is 2 mole of sodium that reacts to give you 1 mole of hydrogen. So 2 mole of sodium reacts to give you 1 mole of hydrogen. This is equal. What does equal actually mean? 2 mole of sodium reacts to form 1 mole of hydrogen. If you have gotten this the other way around, from the equation you have gotten 1/2, and your mathematics will still give you the correct answer. So it does not matter which way around you do. I'm gonna move the mole of sodium, so the N bracket NA is just the mole of sodium, to one side, because I need the mass of sodium later on. Because sodium is a solid, so I can use the relationship of mass over the molecular mass. The molecular mass of sodium from the periodic table is 23. The 2 is the mole ratio, and then multiply by the mole of hydrogen. Hydrogen is a gas, so we are talking about the molar volume of a gas, which is 24 dm cubed for every mole of gas. So that is going to be 300 divided by 24,000. This is dm cubed. The molar volume of gas is also equal to 24,000 cm cubed per mole. It really depends on whether you're given cm cube or dm cube. Because I'm using cm cube, that's why I'm dividing by 24,000 instead of dividing by 24, because there is dm cube. Alright, move your 23 up there, put everything into your calculator, and you should get 0.575 gram, and that is the 3 sig fig. Exactly. Okay, 1 sig fig, 2 sig fig, 3 sig fig. The 0 in front does not count. Next bit is a calculation question. So they want the volume of sulfur dioxide in dm cube based on the equation. So you are given FeSO4 there. So the MR of FeSO4 would be, if you work out in the thing there, is 56 plus 32 plus 16 times 4. So that is from your periodic table. Make sure you know where the elements are, really. The next thing I'm going to do is the mole of sulfur dioxide relative to the mole of iron 2 sulfate. It's going to be 1/2. I could do the other way around, then I'll have 2/1. What does it mean? Sulfur dioxide, there's 1 there. FeSO4, there's 2 there in the balance equation. Alright, so I move everything to one side because I want to involve the mole of, I want to get the volume of SO2, which is a gas, volume of SO2 divided by 24. So if this is in dm cube, then I use 24 instead of 24,000. So that is in dm cube per mole. Okay, dm cube per mole. That is the molar volume of any gas at room temperature and pressure. Yeah, okay. So that is equal to half times the mass, which is 6.08, divided by the molar mass of iron 2 sulfate. I can move the 24 up there and then do my calculations on my calculator. I'm gonna get 0.48 dm cube. The answer is in dm cube as well. The unit given in the answer is in dm cube, so I'm fine there. I need to be careful because sometimes they actually ask in cm cube, so I might have to convert this to cm cube by multiply by 1000 if they ask me in cm cube. So next bit is a calculation question. You should calculate the maximum mass of the ester. So this is the ester. you are given the mass of the propanoic acid. This is a propanoic acid. The ratio is 1:1:1:1, meaning to say 1 mole of this reacted to form 1 mole of the ester. Your final answer is to 3 significant figure. So I will start by working out the mole of the acid. When I say the acid, this is the acid, and the ester is here, okay? So, are you given the mole of the acid? No, but you are given the molecular mass of the ester, which is here, and this ester is methyl propanoate, 88, okay? So there is 88 there. But for the acid itself, you can just work out the molar mass. There's 12 plus 3 plus 12 plus 2 plus 12 plus 16 times 2 plus 1. 74, and then the molecular mass of the ester just now was methyl propanoate, 88. So that's 88 then. So you know that the mole of the ester formed is equal to the mole of the acid reacted. How do we know that? Because the ratio is 1 mole of the acid reacted to form 1 mole of the product, the ester. There you go, based on the balance equation, yeah? So mole, the ester and the acid, they both are given as masses. So I need the mass of the ester. That's what it said, right? You need the mass of the ester divided by the molar mass. So mass over mR, which is 88. The mass of the acid is 11.0 divided by 74. Bring that up, and then you're going to get the mass of ester as 13.08 before I run up to 13.1 gram. Let's do 3 sig fig as required by the question itself, yeah?